Okay, team, we're pretty much going to be wrapping up Unit 9 here in the next video or two. Our test is going to be next week, um, and I'll have more details on that as we progress through this week. I'll get you some review materials and all that stuff. All right, so for this section 9.5 and 9.6, hopefully you already watched my Scratch animation and saw that a rectangle reference variable can reference either a rectangle object or some other subclass of rectangle like square. You can't go the other way around though. I can't have a square variable that references a rectangle object because not every rectangle is a square. So when you are creating objects and assign them to variables, you can always go down to a subclass, but you can't go back up to a superclass. So I want you to bring up this 9.5.4 on CodeHS because it also deals with shapes, and I think shapes is really the easiest way to think about this idea of polymorphism. Polymorphism is, it literally means like changing forms. Um, and what it means is that you can have a variable type and assign it a different kind of object. So in this example, we have a generic shape class. And rectangles, circles, ellipses, and squares are all subclasses of shape. And since they're all subclasses of shape, that means we can assign shape variables objects that are of those classes. Now, what we can't do is we can't go the other way around. I can't go rectangle as you saw in the Scratch thing. I can't go rectangle R equals new shape. That doesn't work because not all shapes are rectangles. Okay. Another example of something I cannot do. I can't go square S equals new rectangle. Not all rectangles are squares. Okay, a square variable has to get a square object or a subclass of square, and rectangle is not a subclass of square. Okay? So the four examples that they have here are all valid, and then I gave you a couple of not valid options there. Now the obvious question is why? Why would we want to do this? Why would we want to make a different variable type and object? And the answer is right below here. It's so that we can put them all into the same collection, either an array or an array list. We want to be able to combine a bunch of different types of objects into one of those collections. If they don't all have a common superclass, then we can't put them in the same. We can't put them in the same group. So if we play this example, it's going to put all four of these objects into the list, and then it's going to call the getName function on all of them. They all inherit getName from the shape class. None of them overwrite it. So it just prints out all that stuff. Now, really quickly, just to go over overriding one more time, since we just talked about that for the first time last week. I'm going to go into the rectangle class, and I'm going to go public string getName, and I'm going to return super.getName plus rcool. And oh, look at this, look at this. So we get rectangles are cool, and then we also get squares are cool. How crazy is that, right? Because both the rectangle and the square are going to use this overridden method. And that's part of polymorphism, is when you run your program, Java's going to go find the most specific version of the method that's available. So it's going to start at shape and be like, yeah, there's a getName function here. And then it's going to go into rectangle, like, ooh, here's a better, more specific getName function. And then for the square, it even looks in the square class and it's like, oh, no getName there. I guess I'll use the one that's in the superclass rectangle. And that's why we get squares are cool as well as rectangles are cool. Okay. Now this example is called shape areas, but only two of the classes have area methods. The rectangle class has an area method, and the ellipse class has a getArea method. So let's go and try and call those methods, because this is what 9.6 is really about. 9.5, what we're in right now, is just simply the fact that you can do this kind of thing. Like that's basically the whole section is I can make a shape and I can assign it any subclass of shape. I can't go the other way around though. 9.6 is about finding the right methods and where those methods are located. So I'm going to jump into that really fast here. So again, as I mentioned, ellipse and rectangle classes have getArea methods, but watch what happens here. I'm going to take my rectangle object, this one, and I'm going to call rectangle.getArea. And I'm going to run it and watch what happens. There we go. So we call getArea and it says that it can't find the getArea. It's like, what the heck? This object, this variable doesn't have a getArea method. And it says that it doesn't have it because it's of type shape. And there is no getArea method in the shape class. But you might be thinking, well, it's a rectangle and rectangles have getArea, so why can't I call a rectangle.getArea? And the reason is because at compile time, when the code is getting compiled and like tested for errors, it's checking this class for the getArea method because that is the type of variable a rectangle is. It's a shape variable. It's not until the program is already running that it goes and finds that getArea method. Okay, so unfortunately, we can't call getArea like this. Okay, we would have to do some casting. So, do you remember casting variables? We did this like way back in Unit 1 with integers and doubles a little bit. In order for the program to recognize that this rectangle variable actually does have a getArea method, you have to cast it as a rectangle. Okay, and I know the name of the variable is rectangle, so that's a little bit confusing. But to cast it as a rectangle, you got to do this. So you put the data type that you want to cast it as in parentheses in front of the object. And then you need another set of parentheses so that it actually casts it before calling the getArea method. Really kind of complex thing. So now if I try and print out the area of that rectangle, it should work. And there we go, 200 units for that rectangle. Now, that's kind of a pain in the butt, having to cast something in order to get access to the methods of that class. So really what we should be doing here is putting a method in the shape class. Now, how do you find the area of just a shape? Well, you really don't. You would be expecting all of the subclasses to override that method. And that gets us into making abstract classes, classes in which you can't actually declare a shape object. I'm not going to get into it because it's no longer part of the curriculum. Last year it was part of the curriculum. Now it's no longer part of the curriculum. So I'm not going to get into it. All I'm going to do is this. I'm going to put return 0. And then we're going to override this method in each of the subclasses. Okay. So I've already got a getArea method in rectangle and ellipse. Now, should we be able to find the area of a square? Yes, because it's the same as a rectangle. It is a rectangle, so that's taken care of. The only class that we need to cover for is circle class. So let's write a get area method for circle. So we need math.pi times radius times radius squared. Okay. So now we can go to our shape tester here, and not only can we print the name of each of these objects, but also get the shape. We can also call get area on each of the objects because they're all shapes and all shapes have area. And there we go. Each object uses the most specific get area method. So obviously none of them return 0 because I overrode the get area method in each subclass. And so they all calculate the areas correctly. Okay. So that is our example of polymorphism, putting different objects attached to different types of variables so that we can put them all into one collection. All right, I'll be back middle of the week here to wrap things up with chapter 9.